And hello, Professor. We are going to discuss our final project by using breast cancer detection. I'm going to explain introduction or overview of the project. Coming to the overview of the project commenced with the acquisition of a breast cancer dataset from Kaggle, which was then uploaded to a GitHub repository. Following this, the project setup was established, including the installation of Airflow using Git's code spaces and and cloning the repository to fulfill installation requirements per repository instructions. And after that, Airflow was subsequently configured to streamline workflow management with user administration and database creation facilitating specialized workflow management and execution rights. The main objective centered on creating DAG, which is Directed Acyclic Graph, to define the data processing pipeline encompassing phases like extract, transform, and load, which is ETL, like data extraction, transformation, and loading, were seamlessly executed within Airflow, supported by our web server configuration for workflow interaction and monitoring. The Airflow scheduler ensured timely task execution and post transformation. Data was integrated into Power BI for critical data visualization and also for analysis purposes, which is crucial for informed decision making processes. Later, my teammate will continue with the next by Manoj Kesani.
Hi, Professor. And coming to the overview, like the project workflow. So at first, we deployed the dataset into the Git repository, and then we have created some of the code spaces in the Git, and we have installed the Airflow and created the credentials and created the ETL DAGs for the Airflow data pipeline. So this is our extract DAG, this is our transform DAG, and this is our load DAG. So let's run the extract DAG. So it is at running stage. So it got success. So this is the extract output table, and this is our transform DAG. So let's run the transform DAG. The input of the transform DAG is nothing but the extract output table. So the transform DAG is running and it goes to success. And we can see the transform DAG output table over here. This is how we have created our ETL process, the ETL phase DAGs. Now I like to ask my friend Indu to continue.
Professor, we have created a DAG. This code for load DAG. The input of the load DAG is nothing but the output table of the transformation DAG, and the data goes to the Airflow database once the load DAG got success. Okay, let's run the load DAG to get the output. Let's run. Okay. Okay, and after successfully loaded the load DAG, then my friend will continue.
So, Professor, now I'm going to explain about the visualization, the Power BI visualization. So, in our dataset, we have two types of cases. One is like benign, and other is malignant. And the benign is like cancer is in the early stage and which is curable, and the malignant is a cancer which is in a peak stage which cannot be curable. And in our data set, we have benign, more cases of benign in the data set. And can I get the next slide? So in this visualization, it displays a comparative analysis of benign and malignant instances, illustrating the patterns in the rates of increase and decrease using cumulative IDs. The data set exhibits a greater frequency of benign instance in comparison to malignant. So now my friend Ojaswi will continue.
Coming to this, we are taking the sum of IDs by comparing the bar graphs. While taking the sum of IDs, the range the range of diagnosis increases like 1.64, and while taking the sum of IDs between the next one, it increases to 1.37. The average, by looking at the graphs, the average is like 61.03 percentage. And while taking the malignant case, the sum of IDs while taking, it shows the range of diagnosis like 2.78, and the sum of IDs are like less than that, it shows 1.4x. The average flowchart, I mean, the average paragraph, it shows like 31. Oh, wait a second. The average, it shows like 36.02 percentage. Uh, Thank you, Professor.